So we need to talk about integer additions. We have talked about some basic components like decoder, multiplexer. They will be using in the processor hardware designing. Now let's see how the addition is performed generally, and then we will use the same methodology to implement the hardware. So you see, if you have a number 7, 0, 0, 0, 1, 1, 1, and 6, 0, 1, 1, 0, and all zeros reading from right to left, what happens when you perform the addition is you perform the sum first. 1 plus 0 is 1, and every bit generates a carry. So when it is not generating actual carry, we say that it is generating 0. Okay, so this 0 is added to the next bit. So 1 plus 1 here is 0 and 1. So whatever the carry is generated here, it will be added to the next one. Okay, so this is how the addition is performed. The binary addition is performed. Okay, so we need to understand there are some limitations, and that limitation is that when we cannot express the result in the specific number of bits, when we cannot express the result, correct result, in the specific number of bits, we call the condition to be overflow. Okay, it says that we are just like pouring the water in a glass, and when it cannot accommodate the amount of water that we are pouring in, it will overflow. Similarly, the result generated, if they cannot be represented in 4 bits, for example, then we will say that it is overflow. So there are conditions to identify when will the result overflow. When you are adding a positive and negative operands, the result will never overflow. Okay, so this is just a rule of thumb. So example, 4 bits, 7 is a positive operand, minus 5 is a negative operand, and when you are adding them together, then the result will always be a positive value. We can always represent in the specific number of bits. Another example, minus 8 plus 7 is minus 1. We can simply represent it in 4 bits. Okay. Next, when you're adding 2 positive operands, okay, overflow may occur if the result sign is 1. Okay, so that makes sense. Of course, when you are adding 2 positive numbers, the result should also be positive. But if the sign bit is 1, it means that the result is negative, which indicates that the result is overflowing. Example, 7 plus 5 equals 12. We cannot represent 12 in 4 bits because the sign is 1 bit, so it clearly indicates that the result is overflowing. Okay, again, be ready for the exam similar kind of question. You might be given a number represented in 4 bits or 5 bits or 6 bits. You will be required to determine whether the result will overflow or not. Okay, similarly, adding 2 negative operands. When you are adding 2 negative operands, the result should be negative, right? But if the sign bit is 0, then it means the result is overflowing. It cannot be represented in 4 bits, just like this. Minus 4, minus 5, it should be minus 9, but we cannot represent minus 9 in 4 bits, and the equivalent value of minus 9 in 4 bits would be this. Okay, it means that the result cannot be represented. Add negation of a second operand follows the same rules. When you are subtracting 2 positive or 2 negative operands, when you are subtracting 2 positive, for example, A is positive and B is positive, and you are subtracting them together, always the result will be smaller than both the operands. Okay, similarly, when so no overflow will occur. It's the same condition that we have discussed before. Subtracting positive from negative operand. So for example, if this is a negative operand and you are subtracting a positive operand, so it will again give you minus A, minus B. An overflow may occur if the result sign is 0. Okay, because both the numbers are negative, the result should be negative. And same is the case with the last one. So this is just a summary of whatever we have discussed. A plus B, when you are performing A plus B, when operands A and B both are greater than 0, the result indicating overflow if the result appears to be negative. Okay, so it will indicate the result is overflowing.